Hey, it's that time of week again. Sunday, 29th of October. I thank everyone who's tuned in tonight. And and tonight we have a pretty exciting show about drones and drone technology by Dr. Paul Finman. But before we get to that, there's a couple things we need to discuss. Uh, we're going to be in uh, at the Biomed conference here in oh boy. Okay, we'll be at the Biomed Expo October 17th to 20th. We plan on having a booth there. I invite y'all to come on down and see us. It'll be at the Alexis uh, Resort downtown. Well, not downtown. Be down off the strip. It's off strip, right across the street from what used to be the Hard Rock. On Harmon. Anyway, so check us out October 17th to 20th. I put a couple links in the email I sent out. You might want to check them out. And they have like 39 speakers and about 70 exhibits in that. So we'll see. Hope to see you there. And we should have a pop up there and with T-shirts and books and materials. Back issues of our magazine all there. And we'd love to see you come by, and we can show you how to get the conference, uh, you know, the TeslaTech conference. Those are available. The complete live stream. You're talking, 33 hours plus, of material up there from the conference. I think y'all would have a great time and learn a lot from that, and even some of the artifacts from the exhibit area will be there as well. And when you click on the go to TeslaTech.info, you click on this logo here, and it will bring up this page, which is shows you how to sign up for it. And as you can see, you have the option to buy the conference. It's a one-time buy, $99, and that gives you the 33 hours forever. And then we also have the T-shirts, available too, there as well. Some great designs in that. So if you get a chance, go for that. It might make a great Christmas gift, if you want to give a gift of information, that'd be the hot tickets, and I also want to let you know we have our TeslaTech YouTube channel, and just go to the TeslaTech.info and you click on the YouTube icon. It will take you right there. We have hundreds of free videos up there. Just hit the subscription. We have a couple of directories, on my website where you can, pick out the conferences you want to see, or by speakers, and we're working on updating the speaker list, And every day I put a couple of videos up there, I'm in the uploading mode. So hopefully you all go and check that out, Now, let me introduce you to our guest, Dr. Paul Finman, and he spoke at our conference, this year. And now he's working on creating a program for young people to get them interested in STEM, and that's what science, technology, what I don't know what the E is, and math, and education for people. And it's a dire need. It's going to be what helps pulls us out of our the issues we're having with global warming and even getting converted over. And one more thing, don't forget to click the thumb on the YouTube channel so we get seen by the search engines. Dr. Finman, would you like to tell more about yourself?
Oh, yes. Well, thank you for inviting me. Actually, I was just talking with you before this, and yeah, I spoke at the TeslaTech conference, this summer, and that was really great. It was a good environment and well managed with the hotel, and then it was just great. There's a great community that's kind of around and interested in Tesla Tech. So anyways, yeah, the last Tesla Tech I think was very good, and I was a speaker there, and I think that next year's Tesla Tech will be even bigger and better. So yes, and then I'm just involved in STEM education now, and working with drone technology, and then I work on experimental physics, and it's just amazing what's possible now with that. That well, public domain hardware and software and artificial intelligence is just transforming science and technology, and we're in a unique period in history, I believe, as far as technology is concerned, and I think it's just really exciting. And then we just have to have the young interested minds, okay, just advancing everything in science and technology. And then STEM, okay, that's science, technology, engineering, and math. And it's a acronym for education. Yeah, it's STEM education. So yeah, I have a new company. It's called ASIM War, and then it's just fantasy gaming and turning it into real learning and hardware. Okay, and then drones are very interesting, and actually they're advancing so much. Actually, they're transforming the real world. Okay, for civilian and military applications. So, yeah, it's amazing what can be done now with just the advanced low-cost hardware. So here I'll proceed. Yeah, here. Yeah, and actually, it's for technology. It's really great that we can do video streaming like this. 5 or 10 years ago, this wasn't possible, but now you have all these systems available at a very low cost, and it just shows how everything is advancing so fast. So, anyways, an outline, okay, for my presentation is, configuring and flying drones is just a lot of fun. And it's a great father, son, and daughter. And I guess I have to be equal opportunity now. And daughters, I think that they enjoy it too. Yeah. So, anyways, it's a way to teach, troubleshooting and making things work, and yeah, the technical skill of making things work. So that's very good, and just the general process and kind of interest in making things work. That will take a student very far in life. Okay, now also just I'll mention AI. Okay, yeah, that's a buzzword now, but it's actually amazing what you can do. Like I have this software package that and subscription that costs $8 a month, and it's unbelievable what you can do for organizing information, and then asking how to debug things and technical information on radio transmitters, and then what's interesting, it has all the ENDF files, and that's evaluated nuclear data file. So you can do advanced nuclear science, okay, with an $8 software subscription. And yeah, it's unbelievable, okay, what can be done now. Okay, now also what's amazing is low cost 3D printing and laser cutting. You can do rapid prototyping, and you can make things at a surprisingly low cost. And yeah, and rapid prototyping and getting quick results and testing things. Yeah, that's part of the technical process. And yeah, it's amazing what can be done there. Yeah. And then gaming technology. The younger generation is very active in gaming. A lot of it is probably a waste of time, but then it can be used in STEM education to capture, students' imaginations and get them active and interested in technology. And then you can do drone simulation, and you can actually do training with these games that are available. Okay, then also the public domain hardware and software make possible the setup of a low-cost physics lab. Yeah, it's unbelievable, okay, what you can do now. When I started my first company, that was 20 years ago, getting equipment and getting started, you needed about $100,000. But now with eBay and then low-cost public domain hardware and software, you can get something set up at a surprisingly low cost. Actually, the first spectrum analyzer that I bought for RF testing, okay, that was around $10,000, and that was a price break at the time. But now you can get these spectrum analyzers and network analyzers. They just use one chip, and it's public domain software and hardware, and you can get them from China for less than $200, and that's enough. It's not professional quality, but you can get the technical data that you need, okay, to experiment with like RF power and communication electronics and nuclear physics at an unbelievably low cost. So there's just tremendous opportunity happening, and technology is just transforming the world, and it's exciting. And then the key is to get young intelligent minds excited in that, and building a better world. Okay, and then drone gaming, okay, can instead of being just a game, okay, it's unbelievable what you can do for simulation, okay, for real life scenarios in asymmetric warfare. Like now in Europe, we have all these wars throughout the world now, and the Ukraine war is just tragic. Okay, and then drones are playing a very significant role in that conflict. And it's so much better to fight wars with, well, it's not good to fight a war at all, but if you're going to fight a war, fight it with low-cost technology rather with human blood. So that's where drones, I think, will play a significant role in transforming the world. Okay, so anyways, drones are a really fun hobby, and you can take out like a high school son and go out. You get some fresh air, and you get some exercise chasing after a drone if it's crashed, and it's just fun. Okay, playing with these things. And then, you just a laptop computer, and you can get a drone configured, and then FPV, first person view, drone flying. You get a camera view of what the drone sees, and and you can fly around and see things. So it's a lot of fun, and it's a good father son or father daughter activity. So that's really good. And then to do all that, it requires technical skills. And so while you're having fun, you're learning every step of the way. So in this picture, you can see these drones, but the drone body is relatively inexpensive because it's just foam plastic. Okay, but then you have a radio and receiver and a video transmitter and a camera and GPS and getting all of that to work. It takes some technical skill, and then you're rewarded by the fun of flying everything afterwards. And then here, I believe you can see my mouse pointer. Okay, is that true? Steve, could you
No, you
comment?
can't see a pointer.
You can't see my pointer? Okay. Well, then I'll just describe. Yeah, right off underneath the planes and to the lower right. Okay, that's a 3D printer. And then the 3D printer, you can print drone bodies, and you can print brackets, and you can print so many things. And this oh, excuse me. This printer that is pictured, that's about $1,000, which isn't too much money, but you can get a good 3D printer, okay, for drone building, okay, and that's $200. It's unbelievable, okay, the quality and the capability of the $200 printers that I have. And then off in the lower left corner, you can see the wheels, and that's for a drone buggy. Okay, and then you have kind of up a little bit to your left, you can just see that there's a laser cutter there. So you can cut out plastic and foam board and cardboard and things. So yeah, so it really doesn't take much at all, okay, to get a very capable drone building capability. And yeah, you can build and test drones, okay, relatively easily, and at low cost. Okay, now what's amazed me in the past year, I've always heard about the buzzword of AI, and okay, but in the last year, it's really broken out, and ChatGPT just does amazing things. Now, I've found a tool, and what these software companies do is they kind of license, okay, Chat GPT and these artificial intelligence engines, and then they embed, okay, that in their software. So Cascade has put together a really easy to use and powerful kind of information management system, okay, for you to organize a technical project. And but what they've done is they've embedded Chat GPT 4.0 is the version that they have, and that's unbelievable. So what you can do is on the right hand side of the screen, okay, you have your Chat GPT, and you can ask it questions and about drones or anything, and then you can copy and paste everything in your information management system, and then you have everything organized. Yeah, so you have all this information that's easily obtained and then stored and organized. And for getting a technical project done, that's just incredible. And it just costs $8 per month. And then even for managing a team, like you can have software developers or technical workers anywhere in the world, and then you can share, okay, this project organization and information management environment. and every you get messaging back and forth. So it's unbelievable the the information management, the collaboration, and the AI all in one package for $8 a month. Okay, now, yeah, so I pointed out the 3D printer, and then you can print a drone body at a mere material cost of less than $30. It takes a fair amount of time, to print something like this, but it's something that you can watch and yeah. So there are all these drone body designs that you can download off of the internet, and then you can just print them out with a 3D printer that costs $200. Yeah, so it's unbelievable the capability that you can do now at a relatively low cost. Okay, and then you can laser cut foam board for a drone. So foam poster board can be laser cut to build a drone body. And here in this picture, that's a drone that's made out of this foam board. And you can buy it from Dollar Tree for $1.25. It's poster board, that people use for signs and displays and things like that. So underneath the drone, you can see this poster board. Yeah, in this picture, underneath the drone, you can see a sheet of this poster board, and that's $1.25 from Dollar Tree. And then you can cut out pieces with the laser cutter, and then you can glue everything together, and you can make a real drone. And this is a drone flying wing, that it's vertical takeoff and landing, and then when you're up in the air, you have it fly horizontally, so it goes very fast, flying horizontally. And yeah, and then I'm working with Xcraft here in Coeur d'Alene, Idaho, and this is a custom design, from Xcraft. And Xcraft will be probably be putting out, these STEM education kits, of pre-cut foam board, and then also you can have pre-cut corrugated plastic, and that's very light and rugged, and then you can just put everything together and debug and test it, and you have a very capable drone from the process. Okay, now gaming technology is, well, yeah, a lot of young people spend a lot of time playing games, but then you can use that in education, and then you can use it for teaching drone flying. Yeah, they have drone flight simulators. So there's so much that can be done there in a very visual and interesting way. And then instead of a young person spending time just playing a game, they can actually be learning, and then receive training and instruction as part of a fun game. And yeah, I'm not a gamer myself, but it's amazing what game packages are available on the Steam website. Yeah, so and then you can connect a drone flight controller to your computer, and then you can do drone flying games on Steam, and that's yeah, surprising capability, and yeah. Okay, yeah. So then you can have this game playing, and you have a fantasy world. Okay, blowing up tanks and everything, but then you can transfer all of that, um, simulation and fantasy gaming into, a real world shop, and then you can build, okay, some very capable drones and planes and everything, with your 3D printer and then your laser cutter and tools and chops and everything. Yeah, so all this can be done in a very interesting and low cost way. Okay, now for just general technical capability and directing that towards like a physics lab, for example, there are low cost open source resources. Now there's AI software, which I've just explained. Okay, and then there's you can get high voltage pulse power supplies off of AliExpress, and they cost about $120, and it's amazing. The, they put out sparks, okay, and the duty cycle of the power supply is very short. But um, you can get like 100,000 volts, okay, putting out a large current for a brief instant. And then that gives a high peak power. So you can actually do respectable nuclear physics with these essentially toy Marx generators from China that cost about $120. And so you can get peak powers, peak instantaneous powers from these high voltage sources for a very brief instant of time. But they can be up to the hundreds of megawatts of power, or even close to a gigawatt of power or a billion watts of power. So it's unbelievable that you can do these things, okay, at a very low cost. Okay, and then actually you can get high voltage RF power supplies also. Actually, the Tesla coil, okay, that's a RF power supply in high voltage, and you can do experiments with that. Now, Mathematica, okay, can be run on a Raspberry Pi, and that is a math calculation program that is just amazing capability for doing math calculations. And the Raspberry Pi, that's a $60 single board computer that it's a full Linux system. So for $60, and then Mathematica on a Raspberry Pi, you can do mathematical calculations that I did for my PhD thesis. Okay, at Stanford. On this very low cost hardware and software. And then you can have open, for nuclear physics, you can have open source alpha spectrometers, and then you can do gamma ray spectrometer. And you can make these for a nuclear physics experimentation. And then also you can get these, well now, the detectors and everything come as a simple low-cost chip. So you can get these nuclear instruments, okay, from China for like less than $500. Okay, and I remember, okay, when all of that was large, bulky equipment that cost $28,000. So now you can get this just off of the internet, and it's unbelievable okay, what you can do. And then there's low cost design software. You can design your own PCB boards, and then you can just send them off to have them made. And actually, you can do a CAD design for different shapes in a drone body, and then you can send the file off, and you can get that as laser cut or 3D printed carbon fiber. So you can get these very light and very strong parts, custom parts, okay, done very quickly and very cheaply. And then you can do all the CAD design. There's some CAD programs for 3D modeling that are public domain and free. And then Fusion 3D, okay, from AutoCAD, okay, for $500 a month, you can get just very professional, full capability software for CAD design, including PCB design. So anyways, it's unbelievable what resources are available now at a low cost. And the key is to get young minds excited in using this and building new and powerful things. Okay, now for a physics lab, you can transmute if you have like a if you have 100 megawatts of peak power, or even up close to a gigawatt of peak power, you can transmute bismuth 209 and polonium 210. And so you can have your own physics lab and work with transmutation and isomer synthesis. And then that's all real physics. And then, yes, if you have a neutron source, you can you can make your own isomers, and you can transmute different compounds. And yeah, you can do advanced nuclear physics. Okay, and then what's really interesting is if you have this high peak power voltage supply, and at hundreds of megawatts of power, okay, you can spark it through a chamber, and then it, like Pepto-Bismol, okay, is bismuth salicylate, and you can transmute bismuth. Well, you can transmute bismuth and Pepto-Bismol to polonium 210, and then you have a whole you have a whole nuclear physics lab that can spin off from that. And in the lower right, okay, you see the black object. Okay, that's the kind of toy pulse voltage power supply, and that actually makes a very loud noise when you spark it, and it flashes, and it's almost like a Frankenstein, okay, science lab, okay, to see something like this. So you can do all this for a nuclear physics lab at a very low cost. And it's just a matter of knowing the science and technology and how to use it. But then a lot of that is just available from an AI program now. Okay, so then, there's just there's significant implications for the future. We're in a very exciting time of technology just advancing so fast. and then you can have you can make things, and you can get information from AI, and you can get public domain software, and so and then you can do all this in gaming, and students can be playing and learning at the same time. So transforming gaming into real life learning and hardware development that revolutionizes STEM education. Then asymmetric war with drone-delivered isomer weapons that will supersede conventional warfare. So with the new technology and low-cost technology that's available, you can have probably like a $2,000 or $3,000 drone, okay, outfitted with, there's some sophisticated, nuclear device in there that isn't too cheap, but anyways, they can neutralize like a $5 million tank. Okay, and then they can do it without exposing, 19-year-old soldiers, okay, to being killed. So then, the asymmetric war, okay, with drone-delivered isomer weapons, is low-cost technology, okay, that takes war away from, shedding human blood, okay, to, powerful technology that is relatively low cost. Okay, now large, centralized, and easily targeted systems will be vulnerable. Actually, at the TeslaTech conference this last summer, I said that you can teach high school students how to have their own little air force with nuclear capability, and then people said, that sounds crazy and dangerous, but that's what's coming in the future. And I don't think that there's any way to stop it unless the world is completely controlled and everyone is monitored. So then the large, centralized, and easily targeted systems will be vulnerable. And so I don't think that they will be able to survive this incredible power that's available now with technology. So what I see coming is we'll have decentralized distributed systems, and they'll have unprecedented technological capability. And then it's just a matter of the young minds, okay, knowing how to do it and make things work. And so you'll have areas, okay, that can supply their own energy and can have their own defense, and they'll just be almost unlimited technology is possible. And then, so with this, there'll be unprecedented prosperity with abundant clean energy. Yeah, if you can make nuclear capable drones at a relatively low cost, okay, then the next step is to apply it to, peaceful energy production. So it's technically feasible, okay, to build your own little micro reactor, and then communities can have their own power supply that is low cost. So energy in the future will be almost free, and then we can get away from the controversy of global warming, and that all economic activity needs to be controlled economic activity generates CO2. If you have abundant clean energy, then there's no excuse for governments to, control everything to limit CO2 emission, because there is no CO2 emitted from nuclear power. Okay, and then I think that there's a potential restructuring of the world order with the network state as a successor to the nation state. So you'll have very powerful technology. It'll be distributed. You'll have defense capability. You'll have abundant clean energy at almost no cost. And then just everyone will be prosperous. And if there are any conflicts, they'll be settled with technology and without human blood. So I'm thinking that we're in a tremendous time of opportunity, and it's exciting. And then all what you have to do is get young minds, okay, excited about it and learning and building. And then that's a path to just an incredible future. So I think that's it. And yeah, so maybe Steve, we could have a conversation, or I don't know if people could ask questions, or if anyone has questions, I don't know if they can go online and ask them, or if they could ask a question in a chat, or if anyone has any comments or questions or anything. I think we have 20 minutes left to cover things.
What you have is on the right. A lot of times people are sending a question on the right, but there's some things I want to kind of comment on, and that would be like, but drones are definitely changing the future. You mentioned about how grandmothers can do this stuff. Well, in the Ukraine right now, there's a lot of grandmothers there who are actually flying the drones, and they've been doing that from day one because they're not physically able to, fight a war physically, but they can certainly fly a drone. And so a lot of them are doing that. And drones have become like a household business there. And they're making thousands of these drones every day and getting them to the front line. And war, as unsavory as it is an impetus for technology in all fields. I mean, you're looking at medical. We have learned so much about the human brain from head injuries, from all these IEDs, like in Afghanistan and over the years, and that it's being applied now. So good can come out. It's a two-edged sword. Good comes out of it. Okay, here you go. How would one go about making a superconductor in your own physics laboratory, say from bismuth?
Yes. Well, okay, there are high temperature superconductors, and bismuth is actually a compound, okay, that can be used. Okay, and then that helps for if you're transmuting bismuth, okay, to polonium-210, okay, then and you're doing that with your kind of hundreds of megawatts of power from a pulse power source. So anyways, there's the copper oxide, okay, high temperature superconductors, and then you can have bismuth in that, and then and then you can pulse power through that, and then that can transmit you have Pepto-Bismol in there with a bismuth salicylate, then you can make a superconductor in your own physics laboratory, and yeah, and have a neutron source, okay, for that. And then with that, you can also synthesize isomers.
And a word to the wise, I better go out and get your Pepto-Bismol now because pretty soon you're going to need a prescription to get it.
Oh, yeah, 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 yeah.
You know, but yeah, I used to make those. One of my back issues of Extraordinary Science back in the 80s. We had a recipe for making bacon, your own superconductors, and then you pour the liquid nitrogen on, and you can get the magnet, which levitates the effect. You know, so yeah. But the dream is to make a room temperature semiconductor, or superconductor rather.
Yes.
So,
Well, okay. Solid hydrogen is a room temperature superconductor. Okay. But currently, the only way is to get solid hydrogen is, under astronomical pressures. Okay, but then you can get surface effects. Okay, so yeah, titanium absorbs hydrogen. Yeah, titanium is a sponge. Okay, for hydrogen or deuterium, and then also palladium is a sponge for. So, yeah, my theory of cold fusion is that they're not understanding what they're doing and they're looking for the wrong thing and measuring the wrong thing, and they're doing everything in a non-optimal way. Okay, but I think that it's a high temperature superconductor effect, okay, that they don't know the details of, and they're not able to reproduce it reliably. So I think that cold fusion is real, but I think the kind of understanding of it is not correct. And then if you do understand it correctly, then you can get abundant and clean energy from it.
yeah, and also like, well, when I was growing up, one of the things me and my brother did when we stayed at my grandpa's house, we used to have like he let us use the basement. We had our own little lab there, and we set up like a telegraph and went into the other, using the old nail and the magnets and that, and you know, and that's what I think, young people, they need is access to something like that, something besides just their computer. Because if you just stay in, your computer, you can do a lot of simulations and that, but it's really when you interact with the real world that things get done, and you start understanding things, I think, you know.
Yes, and then troubleshooting and yeah, that's it. Yeah, so you can do everything on the computer, but that's just the start. And then implementing it in real life, okay, is the technical challenge, and then that's what counts. You want to do something that's real and works.
And I noticed you had some company there to get your like high voltage power sources and that from. Do you
Yes.
know what that was, or?
Well, I can share my screen. I have my browser set up. Okay. So, yeah, here, can I present share screen?
Okay.
Okay, share screen. Okay, and then here, let's see. Yeah.
Yeah, we used to have a company called Information Unlimited, and you could get your high power supplies from that, or you could build your own Tesla coil out of scrap. I've done that. Um, and there's something about like Tesla coils, you hear about them all the time, but until you actually go out and really build one, preferably using scrap metal or scraps, uh, then you can really learn stuff.
Yeah.
There you go. Oops.
Okay, so yeah, there I'm sharing my browser.
There you go.
Okay, and then Yeah, you can get a gamma ray spectroscopy system for like $1,400. Okay, then for the power supply, here, let's see, where is that transforming? Okay, StreamYard. Actually, this is here. Okay, well, actually, I'll just go through these tabs that I have. And then for gamma ray spectroscopy, it's amazing. Yeah, for like around $300, okay, you can get complete gamma ray spectroscopy system to just kind of they're rough measurements, okay, but you know what's going on in some nuclear experiments. And then yeah, there's yeah, and Steam, that's for gaming, and you can get FPV simulator and liftoff, and you can do all that. And then yeah, and then yeah, you can transform fantasy gaming into real world learning and hardware development, which I presented already. Now, Xcraft, okay, that's a company in Coeur d'Alene, and then yeah, they're American-made drones. Everything comes from China now for the equipment because it's impossible for an American company to compete with these low-cost devices from China. But then for configuring everything and making things work, that requires domestic skill. And then maybe with abundant clean energy, manufacturing will come back to the United States. And then actually, yeah, and then Xcraft, yeah, they can, yeah, yeah, you can make these systems. So anyways, now for the actually, I thought that I'd have the power supply. Okay, Ollie, I think. Yeah, here it is. Yeah, so you can buy this as a kit for $54. I don't advise getting the kit because it's pretty complicated to get everything together, but you can buy a finished Marks generator for $62. Okay, so yeah, it's unbelievable. I don't know.
Yeah, but it's from putting the stuff together yourself that you really learn how to do the stuff and how it really functions.
Yes.
I used to take this course, correspondence course on TV repair, and they send you all these kits, starting with a multimeter and working your way up to a oscilloscope, and everything, and eventually you get all the parts to build a TV set, So you learn how it really works, and
Yeah.
and learn how to troubleshoot the thing too. That's important because sometimes when you have a problem, there's nowhere to go. And
Yeah.
if you buy stuff from overseas, well, you know how it is. Sometimes you get on the phone, and those people don't speak English too well.
Well, there's no technical support, and then these devices are actually dangerous. So I don't think an American company can sell these things, okay, because of the legal liability. But yeah, you can buy these things, sold as toys, but they're actually dangerous, and you can do real nuclear physics with them.
And if you're looking at things like to build a big Tesla coil, you need things like a pole transformer and that. Good luck getting one of those. But if you do, be very careful with it, because you could kill yourself with it.
Yeah.
And it's against the law in some states to even sell these things or even possess
Yeah.
them. So I don't know how he survived all these years.
Oh,
I mean,
yeah, yeah.
I
Well,
never wore a helmet riding a bike. Uh, Learned the hard way to ride a bike. A friend of mine told me up. We're going as I'm rolling down the hill. He says, "I'm right behind him, right behind him." I never turn around, he's gone, and I'm flying down this hill. That's how I learned how to ride a bike.
yes, yeah.
Yeah, no helmet when I crashed into the side of that building either. But yeah,
Okay, so and then I have a little bit that I can do a show and tell. Okay, yeah, like this. This is the drone, okay, and this is just made out of corrugated plastic. Okay, so in this case, yeah, there were some leftover political signs from a campaign, and then you can just take those and you can cut them with a laser cutter. Okay, and yeah, and then you add the electronics, so it's a very doable project. And then this design is actually very flexible and powerful. You have vertical takeoff, and then it converts to a wing, and you can put a camera on it, and yeah, you can do border surveillance, and you can do incredible things, okay, with something that's relatively low cost. Okay, then, the raw material, you get this poster board or foam board, okay, from Dollar Tree for $1.25 a sheet. And then with a laser cutter, you can cut out all the pieces and glue them together, and you can make a real, very good drone body. And then, okay, with like advancements in chip and detector technology, like this is actually a real complete gamma ray spectrometry system that costs like $300 or $400, and it gives you a good rough out of everything that you're doing in nuclear experimentation. And yeah, so that's absolutely amazing that you can do that. Yeah, when I was in graduate school, well, actually, I'll show you, okay, what we worked with in graduate school at the Stanford Linear Accelerator. Yeah, so you have this little, detector that's available from, actually, it's from China. They just buy the chips and package them and then sell them back to the United States. And I think this is like $120. Okay, but then here, this is like what I used in graduate school. Yeah, old NIMBIN, and then Berkeley Nucleonics Corporation. And this was all the equipment at SLAC. Okay, and then you can buy this really cheap off of eBay, because nobody uses this stuff anymore. Well, maybe in the national labs and at SLAC they still use it. Okay, but for just a personal physics lab, you can buy this, okay, relatively cheap, okay, from eBay, and you can do real nuclear physics with it. And then actually Maximus Energy, okay, they're an expert in using all this equipment and refurbishing it from eBay. And I showed that for when I was sharing my browser screen. Maximus Energy. They can sell new systems, but then they can sell refurbished equipment. So anyways, all this stuff is available at a very reasonable price, and technology is just advancing so rapidly. It's amazing.
Here's another comment. I just thought of something. Could you use the 3D printer to make low-cost prosthetics for people in need?
Yes, that's being done all the time. I think you just have to do a Google search on that, and you'd get lots of examples of that being done all the time now.
And you can actually make your own 3D printer. You don't have to. And then you can use those these water bottles everybody's throwing away. You can grind those up and use that for your feedstock. Some kids were doing that a couple years ago.
Yes, yeah. No, well, I've seen those, and yeah, you can get your own filament makers. Okay, and then you just put in plastic waste and recycle it as filaments. But then I think there'd be a problem for quality control and uniformity. It takes some setup and some knowledge, okay, to get the 3D printer to work correctly with different filaments. And I think there'd be too much variation if you're making your own filament. And then filament, a kilogram is around $20 to $30. But anyways, just the idea of having your own capability to make your own filament. Okay, yeah, that's good. Yeah.
These kids are making the whole thing, the 3D printer and the plastic bottles they were using for feed, and they didn't seem to have too much of a problem. And for the stuff that most people use it for, you don't need to worry about that anyway. But I went to an avionics show here in Vegas, and they were printing like different metals and everything. And what they'll be doing, I just think they just took one up there to the space station even to try to see how that would work up there on metals and that, because then you could take a 3D printer and you have your own machine shop basically, as long as you got the diagrams, and this is just like on these aircraft carriers and that, the new ones, the Ford class, that thing is built entirely in cyberspace before they laid the first piece of metal down, and they were able to have avatars go through and see, like, is this bulkhead too low or too high? Can I see around this thing? And so they did walkthroughs on that, but everything, every little nail, screw, or whatever, has a 3D, they have that blueprint for it.
Yes, yeah.
So you can really build any piece you need on demand.
Yes, yeah. No, and then that kind of changes the whole distribution system. So instead of having manufacturing centralized in China almost, okay, you can have distributed manufacturing, and then everyone has their own 3D printers, and and then so it's essentially distributed manufacturing.
So the person at home using their 3D printer, using plastic and that, once they got it to their liking, then they can have it made of metal if they need it.
Yes.
There are foundries that do that.
Yes.
So, but yeah. So anyway, we're about coming to the end. Is there anything you'd like to add? And I think one of the things would be nice, though, is if when I was in the military, we have these, like, what they call hobby shops. And you go in the hobby shop, like you go to the automotive, it has all the automotive tools you need. You just drive your car in there and you go check them out of the tool crib and that, and you can go work on your car and stuff like that. We kind of need that for this kind of stuff, because not everybody can go out and buy all this equipment or even have the space for it. If we have something like that, that'd be great.
Well, now they have maker spaces, and then there's So there's a makerspace here in Coeur d'Alene, but it's based at a university. And then I'm surprised at universities and an academic environment almost seems hostile to doing anything practical. Okay, which is not the way it's supposed to be. So yeah, I've been a member of this makerspace, and whenever I try to do something, okay, they tell me I can't do this, I can't do that. And actually for 3D printing, yeah, just getting certified with to operate their 3D printers, was a big problem. And then 3D printing takes a long time. Okay, so if I would have done any 3D printing there, okay, it would have just taken forever. But if you can get a good 3D printer for $200 and you can watch it all the time at your house or in your garage, that's the way to go. You don't have to go to a makerspace. But then for a makerspace, they have a really good laser cutter. And that's about a $40,000 machine. So I'm doing I'm starting to do some experimentation, okay, with their good laser cutter. And then when I have my exact needs defined, I'll just buy one that I think can be much less than $40,000. But anyways, these local community maker spaces provide kind of the community resources for doing these shops.
But they're not in a place where people can get to them easily, and then they don't really push it down like Boy Scouts.
Yes.
That'd be a great place to start introducing people to that.
Yeah.
And so that's what I'd like to see someday. I used to have a museum, and we had all kinds of activities going on. But we didn't have a lot of equipment, set up at that time either. Then we're just getting started.
Yeah.
But yeah. So well, I guess.
Yeah. Anyways, we're in an exciting time of technical advancement. I think we're in a scary time politically in the world. Okay, but I think that there's there's abundant clean energy coming and incredible technological power, and then it's just a matter of, okay, do we go to these very powerful decentralized systems, or do we have just a one world government watching everybody to make sure that they don't develop this or have access to this very powerful technology? So, and then I think that the distributed and decentralized system will win. Okay, but you could have a totalitarian system where nobody's allowed to do anything with technology.
Well, if that's the case, then we're back to Big Brother, and we're also into the Terminator scenario where you're fighting Skynet.
Yeah.
So, and that brings up a point. In about 2 weeks, 2 months here, you can get all the material you need from this, from all these signs you see out there. That plastic material is just what you need, right?
Right. Yeah. The kids could go to town.
Yeah. And do community service, picking up that litter. Anyway, I'd just like to thank you for being here, and I'm sure we'll be touching base soon. In the meantime, I want to remind everybody to go to the Biomed Expo if possible. It's here in Vegas, October 17th to 20th. I will have a booth there, and I'll see you there. And don't forget, we still have we have video on demand available from this year's conference. And next year's conference, we'll be putting out some information soon. It'll be August 6th to 10th. So anyway, thank you again, Dr. Finman, and I'll be in touch soon. And thank you all for coming on, and we'll see you next week, God willing.